Fantastic. Thank you very much, Holly. I am super excited to be back here on a webinar with everybody, which means we've got some exciting things in motion in Team TAD. Thank you to everyone who is joining us for the first time, for being brave to step out of your comfort zone and jump on to chat today. And a huge welcome back to the many familiar faces I'm seeing come in on the line. I was literally just saying, I don't know where this year has gone. So it is unbelievable that we are nearing the end of September. If we can just jump to the next slide, please, Holly. I do want to continue to always acknowledge the traditional owners and First Nations peoples of the lands that many of us are dialing in from today, all around the world, and particularly those at the assets where Oz Minerals does have our operations. Pay my respects to their elders, past, present, and emerging. If we move on to the next slide, like all webinars, we kick off with the Oz Way, and it's actually something that's really near and dear to my heart, and it certainly underpins a lot of what we do in TAD and a lot of what we do at Oz. It is a high-level framework, and so at face value, you could say, well, okay, great, it's just a bunch of boxes on a screen, but when you really look deeply into it, there are a couple of key things that I'd love us to hold in our minds as we step through the webinar and continue on in open house together. A couple of things that are specific is in reference to the strategy wheel right in the center there. On the right hand side, you'll notice that it says lean and innovative. We really do try and approach things with an innovative mindset, and the way we think about innovation at Oz Minerals is about thinking and acting differently. But I want to call out specifically the emphasis on value creation out on the far right hand side there. We think about value through multiple lenses. So we think about the stakeholders and the personification of value through those people. So workforce, community, government, shareholders, suppliers, and customers, which is a new stakeholder group for those of you that are returning to us. We have added that group in acknowledgement to the important role that they play in our business. And we can only be innovative and think about how we can create value for those people if we work together and ask people for ideas and contributions and help us get there. So I'm really excited to have you all on the line today. If we just step forwards to the next slide, if you haven't yet had a chance, when you log in to the open house, you'll notice that we have launched a virtual engagement room. This is a little bit of a first move for us in Team TAD to be thinking about different ways that we can connect and engage with people. The engagement room is a 3D virtual space. It's not going to appeal to everybody, but it will appeal to some people. But what it will do, I think, is help you think differently about how you want to engage with us and what do you want to see. If you've got ideas, if you want to share things with us, even about how it would make it easier for you to connect through this virtual engagement room, please reach out to us. But we will be sharing in this room all of our upcoming challenges, any of our questions, and we hope to be a lot more interactive as time goes forwards when we're working with this space. So next slide, please. Absolutely the reason why we're here today, apart from the fact that open house is new, and I'm really excited for Jess to get a chance to share what she's been building and working on behind the scenes with Holly. And the reason why we've got a couple of key focus areas is the amazing opportunity that's come to us through Calcaroo. And I'm really honoured to be joined today on the line by Richard and Jeff from the Havilah team. I think you can see waving down there on the bottom, fantastic. And Rodney Hocking, I think you might be on the line as well from the Oz Minerals team, who are here to take those technical questions that, let's face it, I'm probably not the best person to always answer. But we've got a pretty meaty challenge in front of us over the next 18 months as we work through the opportunities of Calcaroo. If we pull that time frame right back and we say, well, what are we trying to do in the first 6 months? We really want to get our heads around a couple of key things. Some of it's what and some of it's how. So if we look at the three things on the left-hand side there, about rethinking how project studies are undertaken, testing crowd-based methodologies, and accessing global ecosystems and capability, I think you could say today's webinar is starting to tick all three of those boxes. We really do want to find new ways to connect people into the study work that we're doing on the assets, and to actually share some of the questions and curiosities we have and areas that we're focusing on with as many people as we can to help get engagement and help us think about how we might tackle those. So we didn't just pluck the 3 open house areas that we've shared out of air. We have actually created those through understanding the Kalkaroo project. And you'll notice that I've put a nice big ring around step 4 there, which is about launching some challenges and speaking to people. So that's what's landed us here today. And those key value drivers is what's defined those challenges. There's a couple of other things to just call out that is unique, and over time and in future webinars, I'm sure we'll be able to share more and learn more. We are about to engage, well, not about to engage, we have engaged and we're about to start some core scanning work with a company called Explore. So if you haven't seen them, definitely check that out. And I know Jess will talk a little bit about our Geoshapes challenge, which went up yesterday. The core scanning work is a really great opportunity for us to think about how can we collect more knowledge about an ore body earlier and get higher levels of data clarity and look at it from different perspectives and see how that impacts through the study process and what we actually can, what decisions we can make earlier, maybe what uncertainties we can rule out earlier, just generally, what does that mean? So that company was Explore, who's doing our core scanning. And so we'll share a little bit more about that. I do want to call out a couple of other words on this screen just to put them in your mind, because some of them will be new. Curated crowd. What we're doing today is a part of what we call open crowd. But in a curated crowd, when we will assemble people together to work through specific challenges, they'll be in a more of a workshop manner with a lot more detail shared at that time. By joining the TAD team more broadly and being a part of our ecosystem, you may be called on to and invited to be a part of those curated crowds. So that's a great opportunity to connect. Simulation seems obvious. Simulation is really important as we move more into this digital environment we find ourselves in. But really what this is about is using that data we collect to understand as many possible options and alternatives for design as we can and look at them in as real time as we can and help us to inform our decisions on multiple scenario planning. And then the other one I want to call out is stakeholder value creation metrics. So that is the piece that links to that part on the Ausway I mentioned earlier around our 6 stakeholder groups. Traditionally, when you look at a project evaluation, you really will look at the financial aspects of a project to help you progress forwards. It's not just about finances, it's about the value we want to create for all of our stakeholders, and then being able to look at the trade-offs and the decisions you make as you pick different pathways, whether it's increasing levels of automation, increasing decarbonisation, whatever it is we choose to model and simulate will help us understand what are the impacts on all of the stakeholders. So I'm absolutely super excited to be here today, and I'm really proud of the work the team have done to get us here, and I'm stoked, absolutely stoked, that you're all on the line to have this conversation with us today. So I'm pretty sure that sees me out. So over to you, Jess.
It does help if you unmute. Hi, thank you, Katie. That was fantastic. So I'm Jess. I run the incubator part of TAD, and it's just so great to see some familiar faces and so many new names on the call today. So welcome to all of you, and thank you so much. This slide really is here to show you what we've been up to until now. So as Katie mentioned, we have a virtual engagement room. You can find all of our current challenges and all of our former challenges there. So we ran 6 challenges last year. We've published white papers or case studies for 4 of those, and we've got experiments still running in 2, which is the electric mine and waste to value. So stay tuned for some exciting results and learnings there. What we've done is leverage our learnings from the first round of challenges that you see on the screen to evolve the way that we offer these opportunities to the crowd, build capability, and create mutual value. So we'll tell you more about the open house concept and how it is a little bit different today, as well as some of the more specific areas that we're curious about. We can probably skate on to the next slide. Like I said, we are building our knowledge across the value chain with innovators all over the world and looking to amplify one another's capability. This is about mutual value, and we're excited to see so many faces joining our ecosystem. And when I say our ecosystem, I don't mean TADS, I mean collectively, this group, we operate as an ecosystem of specialists that build learnings and insights and that are accelerated in their discovery. So Katie mentioned it earlier, we believe so strongly that how we work is as important as what we are doing together. And that's really the foundation for the experience that we create as we move forward together. So with no further ado, I'll talk about the open house. This is a new concept for us that we just launched this month. And this is really about inviting people from all industries and all walks of life to share your ideas for new ways resources can be extracted sustainably. We are looking for submissions that help us to get to know you and help us to get to know your idea. What makes you different? How does it fit into the value chain? We've opened up video submissions for the first time. We'd love for you to just come and have a bit of a chat and tell us about your capability. But if that doesn't fit how you like to work, then there's other ways for you to really get that across to us, and we'll find the right way to connect with you that meets the way that you are prepared to talk about your idea. So there's two basic main ways for you to get involved. You can approach us at any time through the open house. So while we will have quarterly review periods for submissions that you think would be useful for our industry, it's always open. And that's really the new part of this. It's a great way for you to stretch our thinking towards something that could add value, but isn't being specifically sought out just yet. And when we select ideas every quarter, we'll support those through collaborative experiments, accelerated investments, or pilots. You can also participate in specific challenges still. We're calling those the rooms in the house at the moment, and Holly's going to talk to you a little bit more about those in a minute. But in addition to that, that ecosystem is someone we call on quite regularly for things like the curated workshops that Katie mentioned, technology calls where we really want to accelerate pace in a new way, or focus on areas that we're particularly curious about together. So there are 4 specific challenges right now running alongside this open house, and I will let Holly walk you through what those look like.
Thanks, Jess. And hi, everybody. I'm Holly from the Unearthed team. Now I'll take us through some of those specific challenges that Jess mentioned, but as Jess and Katie said before, we've got the subject matter experts on the call as well, so we can go into more detailed questions about any of these areas after we do this run through. So please pop your questions in the chat or have them ready for when we get through that. So as Jess said, the broader open house is open at any time for any kind of idea and solution that could apply to the whole of the mining value chain. But there are some specific areas that we're really interested in at the moment. And the first one of those is material movement, and really how we can move materials more efficiently and sustainably. So as in many mining operations, whether it's kind of surface or underground excavations, we do obviously fragment material and then move this using kind of a combination of different earth moving equipment, and both from an ore and waste perspective, and we're typically transporting that material elsewhere to be processed or disposed of. And so you can see how the volume of rock that we're required to move is really substantial. So what can we actually do, or what existing or novel technologies can we leverage to help reduce the overall emissions associated with material movement, which can be quite significant. So we're really looking for solutions that focus on how we might employ different technologies to reduce those emissions, but also how do we holistically look at automation options and other ways overall to improve our sequencing and processing rates. So material movement is the first room in the open house. Next, we come to thinking about in-mine separation and pre-concentration. So here we're talking about how we can extract valuable material much more precisely and sustainably to lower our footprint. So the opportunity here, particularly as ore grades decline and we're resulting in having to move greater volumes of waste rock and using more water and more energy, how can we focus on developing new and sustainable practices that reduce our footprint and help us kind of extract just the material that we want. So in this room in the house, we're looking for ways to improve the separation of valuable material from waste material and pre-concentrating that. So for example, can we more effectively sort materials where they're initially fragmented to reduce the overall material that we need to move, or can we more precisely break and separate valuable materials from waste in the first place? The next room in the house that we're looking for at the moment is around slope engineering, and this you'll see when we can talk more in detail to talk through how this particularly applies there. But another key area, particularly when we have soft overburden, is we need to really optimize and stabilize our slopes so that we can move less material. And again, this comes back to how we access minerals more precisely and stabilize the slopes in our operations so that we can enable less material to be moved. Obviously, safety is a really, really key part of any operation. And so this really includes the way that we design and stabilize the walls, particularly in an open pit. So as technology changes and we can automate our operations, how does that help us rethink slope engineering to move less waste materials? So yeah, as I kind of said before, in many surface mining operations, for those that might not be familiar with open pit, we do kind of create these shallow angle pit walls to reduce the risk of slope failure. And this is particularly challenging in operations where the material is quite soft. So how might we be able to stabilize this and result in less of that material needing to be moved? And the last challenge I want to talk about today is a little bit different. So this is particularly in a data science space, again with ORExplore, as Katie mentioned, the partner for doing the core scanning work. In this challenge, we're actually providing people with a synthetic data set of 3D scanned core to see if we can better identify minerals within that rock automatically. So if we think about it, we're trying to understand what are the mineral shapes that we are experiencing in drill core, and what's the orientation and size distribution of that, because that helps us understand more about the ore body to help us better understand how we might be able to effectively extract the valuable ore within that. So you can check that out via the engagement room as well. So that was a quick run through, and I'm going to hand back to Jess now to talk about how to get involved in the challenges.
Absolutely. And I do actually recognize some of these names who are asking questions as people whose submissions we've been eagerly scanning already. So it's great to see everyone so involved. So in addition to participating in challenges, we're constantly looking for people and organizations aligned to our mission to bring diversity of thought to our ecosystem. So if you'd like to be kept abreast of the work we're doing, but you're not ready to complete a challenge submission yet, or you're just keen to lean in and add value through your expertise in another way, you can register your interest in our virtual engagement room, or you can apply for the challenge itself there. The best way to get involved within an existing challenge is probably just in that way. So just to respond to a question on the fly. So if there's a challenge that's already running, I would say create an open house submission, because the way that we manage our cohort processes is that we'll bring you into the right conversations at the right time. So that would be, I'd say, the best way to do that. And if we have some curiosity, we'll schedule some sessions with you to get some, I guess, more understanding and feedback on your submissions as we go. So as we dive into Q&As, it's great to see people popping them in the chat, and I'm trying to answer them as we go while I stay present to the discussion, which is an ongoing challenge in online facilitation. I'd like to just introduce Rod Hawking, Jeff Borg, and Richard Buckley, some technical subject matter experts who are familiar with Kalkaroo, familiar with the mining value chain, and familiar with the work that we're doing here together. They're both from Havilah and from Oz Minerals, and we're conducting this work in partnership. So thank you for being here to help answer the questions from the group as they come in. And I'm just trying to follow along in the chat as we go. So please pop your questions into the chat, or feel free to put your hand up. Can you put your hand up in Zoom, actually?
No, I
no.
don't.
Feel free to just, I guess, put your questions in the chat. It's probably it. Oh, there you go. James has just taught us how to do it. Thanks, James.
There you go. You can. And maybe, I mean, I can help by reading some of these out loud so we can answer them for the group as well. So I might just pick one of the questions that came through is mining tailings included in this category?
Look, I think the most important thing I can say is that everything is included, and that's the fun part of the open house that we're experimenting with. So we know that, like Holly was mentioning, separation and pre-con, slope engineering, materials movement, the data challenge, these are specific areas that we know we have a need in, but we also believe there's probably stuff that we haven't even thought to ask for yet that you might be able to introduce us to bring value into what we're doing. So if you have a great idea that you think can improve the way that we conduct anything to do with the design, the build, the operation, the decommissioning of a mine site, that's something we're really excited to talk to you about. And you can use the open house at any time to bring those ideas forward to us.
Yeah, awesome. Thanks, Jess. And I might just reiterate, I think you've answered this question probably exactly just now, but from John, talking about, obviously this is part of the value chain, but how are you integrating the discussion around energy, wind, solar, batteries, including vanadium batteries, and energy requirements? Yeah,
look, we're definitely interested in novel ways to create and to use energy on a mine site, and potentially even with the broader community. We've definitely been doing work in this space way back, there was a hybrid plant at Carapatina that we did some experimenting with. We ran challenges last year, so you can read more about the learnings that we've had so far through hydrogen hypothesis and through scalable and adaptable. But we're always looking for groundbreaking new ways of managing energy. So if there's something that you think we need to know about, then an open house submission is a great way to get that technical idea across to us as well.
Awesome. So Stefano's asking a few questions around getting involved in a challenge. So I might package those together. So talking about happy to compete, but first like to get some feedback on the technology. So it might be worth exploring like kind of how we do that through the process. And then also a question about what are the benefits of taking part in the challenge, like investment or meeting other mining companies, things like that.
Yeah, absolutely. So how to start? So TAD, basically, we've built an experience to bring our innovators together with the right people in our business, with the right people in the broader ecosystem, and that does include other mining companies at the right points in the conversation, or just with technical SMEs or with one another. So we facilitate fortnightly roundtables with cohorts at the times that the innovators select based on their geographical location in order for them to come together to share progress and share learnings. They set goals, they get feedback from their mentor that we find for them in the ecosystem as well, based on the experiment they're running. And we also create a customized capability uplift program to help innovators get the most out of their experience and out of their experiment. And that might be for people from other industries who are trying to tap into mining for the first time. We run a Mining 101 value chain workshop so that you can understand how the process works at a high level, and then an opportunity for Q&A with some of our more technical SMEs. Or it might be pitch coaching so that you can get your idea across and pitch for investment, or I guess an experiment or funding in sort of a more articulate and connected way. So everything is part of a system, and we're here to help connect you in that system so you can create the most value for yourself and hopefully for us at the same time.
Awesome. Now, I know, Krishna, you've said you've got some comments, so I might just quickly go to Herad's question and come back to you, Krishna, to come on and chat to us. So Herad just asked what TRL we're looking for.
Look, so the exciting thing is there's more than one way to fry an egg, right? So TAD has quite a few things going on at the moment. So if you're looking to do a finite experiment through the incubator, then your TRL might be a bit lower. And that could mean that you have something that has a higher TRL in a different industry, but we don't understand how to apply it in the mine site yet. Straight through to you might have something that you believe could be rolled out quite quickly and add value differently, and that might be a higher TRL, and we'd find a different conversation to have with you about that. So I wouldn't suggest that you should constrain yourself in terms of TRL. The way that we approach your idea might be slightly different, but that's for us to work together on after your submission's complete. So don't hold back, I guess, is the advice I have.
Thanks, Jess. Krishna, did you want to come up and ask your question?
You are on mute still, Krishna.
Yeah. I'm
getting good at lip reading, but I'm not that good yet.
Yeah, I succeeded in. So I hope you can hear me.
I can.
But in general, first comment I had was kind of more general. When we were talking about the opportunities, I presume Kalkaroo is a mine.
Kalkaroo is currently just an undeveloped resource.
Undeveloped resource, okay.
Yeah, and all of us would love to see it as a mine. I think would be the way to say that.
One of the things that item 2, we talked about was test crowd-based methodologies. And, in participating with the ingenious extraction cohort, what I learned was this is a modern way of new process development. In the old days, one used to run lab scale experiments, and then you go on to larger scale experiments, to pilot plants, to commercial plants, and now that was, I would think, kind of a sequential kind of thing. Now, this new methodology, crowd-based methodology, kind of is a novel way of looking at this thing, because it helps us get a lot of ideas in the initial stages of a project. So, whereas there the thinking is done kind of almost in individual departments and boxes, so it's compartmentalized. So I see values of the approach that we are using here, Now, but what we should also bear in mind that there are some established processes for methods, steps for process development, that we don't shortchange any of those. Because my experience has been, I've been in research at ASARCO and mainly at ASARCO. I started out in the Central Research Department, and I found out that at times we have kind of cut corners and not done one step of a process. And ultimately, that's a process, that is a step that sinks the whole process. For example, we developed a process where we forgot about recycling the dust. And ultimately, that proved be to the thing that killed the project. So again, I think there are, and also I'm kind of thinking of writing a book on the subject, on innovation itself. And certainly one of the things I'd like to talk to you all, the right people, to make sure that I'm representing the TAD process and what we are going through accurately. Okay, so that's my kind of overarching comment. And the other thing I also, amongst the things that you all have in mind, what grabs my interest is in-mind separation and pre-concentration. And again, this flows out of the ingenious extraction process, where we proposed a fluid bed roasting of concentrates. Now, my sense is, by the time you get to concentrate stage, my understanding, I had done the calculations many, many years ago, and 2/3 of the energy and 2/3 of the cost had been expended by the time you get to concentrates. So I would like to term this thing designer concentrates. So if you want to do hydrometallurgy, you want to design your concentrate so that at the beneficiation stage or milling and froth flotation, for example, you try and get rid of things you don't want. So that a concentrate meant for smelting is a lot different than a concentrate meant for hydrometallurgy. And if there are opportunities where I can help kind of mold this process, I think, and I was thinking, if we have some projected of this resource, and we can kind of at least get some examples of what the gangue minerals might be, how it might be extracted, then maybe we can use that as an example. So those are my comments.
Krishna, I think there's two things in there, which is fantastic. The first one there, around the study, I couldn't agree with you more. As we try new things, we don't throw out the old. And maybe in future webinars, we can talk a little bit more about the integrated approach that TAD is taking to resource to reserve development, because we are absolutely not ignoring the important kind of due diligence work that goes on behind the scenes, but maybe challenging the how we get there. And in that, I'd call out, I think you can see Rodney's head on the screen there. Rodney's actually also the study manager for the Kalkaroo project on the Oz Minerals side. And Richard and Jeff have worked on this project for many, many years and looked at it through many lenses. So having that kind of grounded multi-team approach to the resource is, I think, how we will be looking to avoid making those errors. And I really appreciate you calling that out, and please do continue to do so as we challenge new things. The second one, I actually would love to see whether Rodney or Richard have got any thoughts as we're talking about some of the work maybe that you've already done or looked at and thought about in terms of pre-con and or separation works. And in addition, Krishna, absolutely, we can engage deeper into that conversation as a part of an open house submission if that's an area you want to work in. But I don't know if Richard or Rodney, you want to make a comment on that.
Yeah, thanks, Katie. I can make some comment. So, Krishna, we have done some work on ore sorting, particularly in the Kalkaroo's actually got 4 different ore types, so it's a very interesting resource. And the last ore type, deeper sulfide, is chalcopyrite, and that is quite amenable to ore sorting techniques, and that allows us to to look at upgrading it from a sort of 0.5% through to a larger percentage. But as you're well aware, you actually need a fair big sample to actually run through that sort of process as well. So we're sort of at that stage where we've done some I suppose you call them lab scale work, but not progressed onto the larger scale work just because we don't have the sample. Cycling back a little bit, I probably should just give an intro to the project as well, because I noted that you wanted to know whether it was a mine or not. It is a resource, so it's been drilled out to a reserve, and it's past a PFS sort of stage. And we've done a lot of work over the years in some of these other aspects that the TAD team, in partnership with all the people here, are hopefully going to contribute to. And that is, we've done a fair bit of work on the geotech side of things. And we actually opened up another mine a few years ago, about 5 years, 6 years now, 20 k's north of Kalkaroo, and we dug in the same material. So the material is very soft. The overburden is very soft. It's very amenable to free digging and conveying and those sort of processes. But it's overlaid by between 40 and 60 metre of thickness, and it's the actual overall thickness that contributes to the instability. So it's not actually anything of the material type as it is. It's just the overall thickness, and obviously that contributes to weight, and then we have to have the appropriate overall angle for the weight. So that's one aspect. The other thing is the area that we're at is probably the sunniest and windiest place in Australia, although I'm sure a lot of people put their hand up for that. We're about 70 k's from a wind farm at Silverton. So, that's great in terms of looking at renewable energy. And finally, I don't want to hijack the group, Katie. Finally, I just wanted to just bring up the tailings, and that's a good comment, because currently we're actually producing a pyrite concentrate, which has quite a significant amount of cobalt and gold in it, and we need to try and find either a market for that or some way of adding value, because we don't want that to go into the tailings, because there's actually value in it. So, those sort of concepts, I think we've done a bit of work on that, but it's the chicken and the egg with those sort of concentrates. They sort of say, well, we'll give you the price when you give us the concentrate. So you don't know what value you're getting out of it. Anyway, I've spoken too much. I'll let the other people have a chat now.
Thank you, Richard. I think that is, informative.
Definitely not spoken too much. That's why you're here. Thank you, Richard. I appreciate it.
Anything additional, Rodney?
Specifically around pre-concentration. Yeah, so if we look at the ore body, there's, from what I can tell, some of the standard approaches, so separation in bucket, separation on belts, etc. And then also on top of that, exploiting particle sorting and things like that as well. There's probably a few different pathways that we need to explore at the study. Notwithstanding, some of the ore is quite soft and therefore can be quite cheap to process anyway through sort of gravity methods, etc. So it's probably not necessarily as interesting if you can process it cheaply. Interested in novel ways of leaching potentially as well, in terms of not necessarily in situ. And then if we start thinking about the overarching tailings discussion, obviously the coarser you grind, the lower your separation, but then the more amenable it is to using the products outside of, or basically not having any tailing streams at all. So I'm quite interested in ideas around coarse particle flotation, etc., but also ways of getting the ore body and testing it and looking at other ways of removing tailings from the ore stream that also could potentially create revenue.
Thanks, Rod.
Thanks, Rod. I think David Tavi, you said you'd like to jump on and comment on material characterization.
Yeah, thanks for that. It really is a comment, but initially thanks for the introduction. It's all really good stuff. Where you're going with characterizing your ore body, let alone any material in your ore body, and that could be the payable mineral, let alone any other related mineral, is very good, and the technologies that are evolving in that in Australia are world class, and they help for the overall sustainability of the material. So the core scanning stuff is fine. Where I'd like to sort of take that then is into waste and development of co-products. Unless you characterize all your materials at all stages as you're evaluating them, then it's very hard to see whether you can utilize or sell these things and therefore optimize back onto your process. And it was a bit like what I think it was Rodney mentioned. How do we deal with the cobalt, a pyrite concentrate that comes out on the current process flow sheet when you don't have a market? Well, that's the definition of value in use. You have to evaluate any material at any stage. So one thing we're actually missing here, day 1 through to day 10, is a valuation related to use or market. So I'd just like to put that out there. So value in use studies will be very, very important. You don't need to make them Ben-Hur and bigger than Ben-Hur and overarching. They are iterative along the way, and you test those on any mineral, any matrix, or any element in the periodic table that you can identify day 1, let alone day 10. So let's not get carried away, but it's really the process of assigning a value, because unless you can put a value in there, all we're talking about is costs, and you can't then benchmark your optimization because you don't have a return side of things, which is value. Price, if you want to go there at the end of the day. So look, I'll just park that there. But I am enjoying the conversation, and it's great that we're looking at individual deposits, let alone a way of doing business in this way. So I'll leave it there. Thanks.
Thanks, David. I'd love to continue that conversation further. So I'm really glad you raised it. So we'll have to catch up through the open house and see what we can pursue in that path.
Yes, you owe me a coffee anyway, Katie. We've been trying to touch base for about the last 3 months, but
more than one, David. So we'll make good on that.
I am just down the road from you, lady. So I'll buy you the coffee, and if there is a coffee machine, that's fine. Okay,
sounds great.
Thanks.
Sounds great.
Fine. I'll see you soon.
Brilliant.
And Krishna, you said you had one more question?
Yeah, and actually turned out to be 2, and maybe related. One was this issue of tailings dam safety. I think that's kind of an important consideration, and building that into some of the activities is worthwhile. One I've seen on a slide CT scan. Is it referring to the medical CT scan? What are we analyzing the mineralogy of compounds, or and is that available on online? Are there sensors available to measure mineralogy online? Because there are many applications where we could benefit from that.
Oh, I think I've unmuted. Krishna, yes, the Geoshapes challenge at the moment's got a synthetic data set that'll be somewhat similar to what we produce from the core scanning, if not exactly similar. I don't want to be held to my technical clarifications here, so Holly, please correct me if I've stated that wrong. And we're going to be working out over time what we can do with the collected data set on either this asset or future assets, should we continue with to see how we can use that data through the process differently. So there will be example data sets that will start to be made.
You're starting to break up a bit, Katie, but
yeah. I was just going to say the reason I'm asking that is one particular example that I see is, at the company I worked at, Asarco, we have a smelter, and in trying to predict when you smelt the concentrates, what kind of product you produce, you need the mineralogy, not the elemental compositions. And I was just thinking that if online sensors which could measure how much different minerals are present, because that's what the form of the chemical compound is what determines how much heat will be produced in that process. So I don't know where that technology stands. And it kind of seems to me that if one can develop sensors that do that, that will have great value in many, many industries. I think that's about it.
Thanks, Krishna.
Stephanie?
Stefano? Yep.
Oh, yes, thank you very much. A quick technical clarification. So concerning the slope engineering challenge, I think it was specifically mentioned soft soils. So let's say my technology would be for any type of slope, and it's really about getting steeper slopes, so less waste rock, less waste ground, let's say, without compromising safety. I was just wondering why the specific mention about soft soil, or because to me, like whenever we have open pit mines, you have a variety of soils and rock, sometimes strong rock, sometimes less strong rock. So it was just a curiosity towards that mention of soft soil.
Yeah, I can take that if you like.
Thanks.
So it's interesting. It really needs, I suppose, if I had a cross section, Stefano, I could really show you what I mean. But this material is an interesting material. It's very soft. It's not a soil. It's more of a clay, but it's not a saturated clay. It's up to 40 to 60 meters thick, pretty much from the surface. And then once you get past that material, you basically get into the ore package. So, which again can be weathered at the top of it, a saprolite, and then it goes into the harder saprock material, which is more conventional drill and blast. So most of the overburden and the current ore reserve within the pit, we've got 100 million tonne ore reserve at about a 3.5 to 1 stripping ratio. And most of that overburden is actually this soft material, which can be freely dug. It's not, and the reason we know that is because of this other operation to the north of Kalkaroo, which we actually mined as a gold-only operation, and we mined through this material, and that enabled us to do a lot of work on all the geotech sort of angles and the requirements, and we've built up a massive amount of data around that. So what would really move the dial here effectively, if you could just think about it, if you could actually move that 50 meters of material very cheaply, you're exposing the ore body. So the ore body becomes in effect at the surface now. Now, if the ore body was at the surface, it wouldn't be there. Someone would have mined it. So that's the challenge with these things, is to come up with some ideas around that. It's not hard to move. I mean, at the other operation, it was very easy to move that material. It's just that overall, we had very low batter angles, and they were required because of this thickness.
So if I understand correctly, you would like to have some ways to get the steeper angles. And just a quick clarification on this. Is it cohesive, this type of clay? I guess it has like a sort of...
I'm not sure if you're still there, Stefano, but I'll answer the question. It is cohesive, and basically the the material itself is you could stand a wall up quite steeply. It's just the thickness of the material. So what happens is that if you've got too steep an angle, you're going to get a circular failure occur. Now that occurs over a couple of months. It's not a failure that occurs instantly. It's something that you can monitor and manage, but that's what happens, and we've seen that, and we know exactly what angles we need to cut in order to mitigate those issues.
All right, Wilco, go for it.
First of all, apologies. I've been clapping constantly, but I was trying to put my hand up. So, figured it out now.
I'm just excited to be here.
I am excited. Yeah, I know it's great to see all the interaction, all the conversation. So that's good. I just wanted to make sure, Jess, that I understood what you said correctly. Because we work with different mining customers, so we've worked in all that exploration space, but also in sort of that understanding the ore resource and coming up with new techniques to better classify that. We also recently released capabilities that help radiation oncologists to look at MRI scans to find cancerous cells, which I think is a really transferable technique to the ore. The ore explorer. Now the challenge that we have is that Unearthed is locked into the Python side. So can we use the open house to submit to reply to these challenges if we don't use Python?
So for the data science, this particular data science challenge, we have asked for Python because that is what will work with the Ore Explorer database. But that's not something that we want to necessarily stay constrained on. So I think it might be worth a further conversation, Wilco, and I've just made a note of that so we can have a chat about how we might be able to make sure we don't unnecessarily constrain things. The reason for that is just with the synthetic data set and this being our first data challenge, that is the language that we can best use to move quickly for Calcaroo, but to create longer term value, there might be some other ways that we can have the conversation.
Yeah, and we're happy to show what can be done without being rewarded for that from a challenge point of view, but yeah.
Right, I've just made a note, Wilco. I know how to get in touch with you. Thanks. You.
I think
it might be worth having
have a quick look at this one because it is really unconstrained compared to some of the other challenges which have had specific machine learning frameworks for deployment purposes. So this one is actually very broad, and the only constraint is in Python. So there might be some conversion there, but it might be a bit easier for you guys on this one.
Okay, thanks for that.
David, jumping in.
Yeah, thanks for that. And I did put up a comment there earlier, one to support Krishna and Rodney and Stefano on commentary on the overburden materials. It will always come back to characterizing that material, and ultimately Krishna is right. It is the mineralogy of those materials, waste in this sense being overburden, and how you deal with its physical and chemical properties that ultimately will reflect on whether you have a pit wall failure. So until you start this whole process of characterizing as an overarching word, I'll use, and then as I mentioned before, carrying that all the way through to your production process. I'll just introduce a thing I worked on many, many years ago, and it went over the head of every lawyer that was in the room. There was a project called the White Octopus, and it was driven by utilization of 2 to 4 million tons of chemical processing waste. It was a phosphogypsum in this case. And the thing that made it very worthwhile in a cost recovery sense was the Department of Main Road was actually importing similar materials from around Australia to mitigate the sodic soils. It was to soil condition. They were importing material already up a very long supply chain, and this material was sitting there. So it just happened to be a bit of lateral thinking between what was considered a toxic waste and the cost of storing that. It was about $25 a tonne storage over 2 to 4 million tonne a year. So it was a big operation. And here you had a government department wanting this type of material. Just happened that this material was white, and it ended up doing, I think, 8 roads, 200 kilometers long. So ultimately it looked like a fairly large white octopus from the satellites. And it solved 2 problems, and in fact gave a $25 cost recovery. In fact, the Main Roads Department ended up buying this material for a pittance of what they were already paying for similar materials. So it's not hard. It just starts with characterizing every grain that you're going to move. And so Krishna's right. It's ultimately the mineralogy and the physical and chemical properties of the mineralogy, ultimately. And that just goes through.
David, just to follow up with one more example, at ASARCO, we did research with the University of Arizona Civil Engineering Department, where we took flash furnace slag. It's an Inco flash furnace slag, which is a copper smelting slag, and mine tailings. And we were able, and through alkaline treatment, we were able to convert it to a geosynthetic polymer that could replace ordinary Portland cement. And in lab scale tests, this thing, in terms of it compared favorably with and had comparable or better curing times and strengths properties. But again, because of the that it's coming from a waste, there are many it is considered liability issues, legal liability issues, which are kind of magnified in the United States, so those cause problems. But again, that's another idea that I think, because for most of our construction materials, we are dependent on naturally occurring rock and sand and gravel and all that. Those we are going to run out, but we will have huge piles of tailings and slag. And if we can use that to reduce greenhouse gas emissions, so that would be another idea. And I don't know where or on what stage of our process it might fit. But if we could discuss examples like that, maybe it gives other researchers some ideas on how to proceed.
Yeah, it's a very good example that you're using there. And it all comes back again to this characterization and then looking laterally at the potential uses. And we tend to focus on the cost of producing that, whereas I actually don't understand the word waste. It's not really part of my vernacular. You want to optimize the use of the materials you're digging up, and some of those you can sell, some of them you may have to bury and otherwise. But building materials is one area that we as a mining industry, being focused on metals particularly, the metal side of it, disregard, because we consider overburden waste and we consider processing waste. As I said, I can't really understand the word.
This has a number of parallels, and I really would encourage Krishna and David, both of you, to even put an open house submission in with just this as a topic, even without fleshing it out, to remind us to link in with you to have this conversation. I know Rodney's looking at waste products through the study. We're looking at the same concept. There's value there. We're also talking about, as Rodney mentioned, the leachability of material, which some may call waste, some may call low grade, some may call something entirely different. But there's lots of different opportunities when you look at it from a systems view. So I'm really glad we had this rich conversation today, and I hope you both put something in to link in.
Yeah, look, it's already been recorded, so I won't put in a submission. We can follow it up over coffee.
Yeah, David, if you would like to connect, if it would make sense. But I was also going to say that, unlike you, I think you invited for coffee. If I were to invite Jessica or Holly, they'd have to come to Scottsdale, Arizona. And we're trying to sell our house in Scottsdale and move to Dallas, Texas. So my home base might change, but I'm glad that you're on the same time as Singapore. So, I talked to my son and my, granddaughter. So the timing is really fine for me,
Yeah, well,
You
sell up
always
in
have coffee over the internet.
yeah,
Okay.
sell up the Scottsdale home and move to Adelaide, and you can change your coffee for wine. So it's
God,
Well, look, we might start to wrap it up there. So I might hand over to Katie and Jess for any final comments.
Look, I'm just really, really grateful for the rich conversation and the leaning in of this ecosystem and the questions. And it's been fantastic to have all of you here. Wilco, I'll catch up with you separately on the back of some of your questions. And we've already gone through anyone who's made a submission. We've actually looked at all of them already. We're so excited and so eager and looking at these ongoing. So please continue to make submissions. Make sure you make it clear to us why you're different and how you fit into the work that we're doing. And if we're not sure, we'll ask you, but we're really looking forward to understanding how we can all find really new ways to unlock value together. So thank you so much to everyone today. And Holly will send the link to the video around. It will have the link to the slides in it. I know there was a question around the value chain. So you don't necessarily need to show exactly which faces you connect to. That's probably more detail than we need, but where in the process you connect to is a really good idea. So thanks for pointing that out in the chat as well.
And I also want to further thank our technical mates for joining us today and fielding those questions. So you certainly got me out of trouble, Richard and Rodney. For that.
Definitely. Really appreciate having Richard and Jeff and Rod here. Thanks so much. And thank you, Holly, for hosting us.
No problem.
Thank you all.
Thank you so much, everyone. And yeah, I'll send through the link to the recording, and have a fantastic day wherever you are in the world.
Thank you.
Bye-bye.
Thanks for the opportunity.